This video is about solving for a missing value using properties of similar figures and setting up a proportion for real life situations. So in number one, we want to write a similarity statement and state why the triangles are similar, then solve for for x and y and find the similarity ratio. So if we look at this picture, we have a triangle within a triangle. So the two triangles I'm going to look at are this smaller triangle and this larger triangle. Now, both triangles have C as a vertex, so that is one set of our congruent angles. Then, because the lines are parallel, BD is parallel to AE, we can use corresponding angles. So we now know that triangle, and you can pick whichever one, so I'm going to do the smaller one first. BCD is similar to triangle ACE by angle similarity. So now I'm going to solve for x and y. So if I'm solving for x, I see on this side where my x is, I have from the smaller triangle the side of 12. This whole side I have to add together. So 4 plus 12 would get us x plus 16. On the other side of the triangle, by C, B, and CA, those all are numbers, so we can use that to set up our proportion. So we would have 6, the small side of the little triangle, over the whole side, which is 8 plus 6, to get us 14. So now in order to solve for x, we are going to cross multiply. So when we cross multiply here, we're going to have 6 times x plus 16 is equal to 12 times 14, which is 168. We can distribute the 6, so we get 6x plus 96 equals 168. We can subtract 96 on both sides to get 6x equals 72. When we divide, we get x is 12. Then to solve for y, I'm still going to use this 6 and 14. So I'm going to have 6 over 14 equals, the side from the smaller triangle is y, over the side from the larger triangle, which is 28. So as we cross multiply here, we get 14y equals 6 times 28, which is 168. So when we divide, y is also going to be 12. When we look at our similarity ratio, remember that similarity ratio is the ratio of your sides. So it is going to be the old triangle over the new triangle. In this case, we're looking at our statement. So the old triangle is BCD. So we'll pick one side, we'll pick 6 over the side from the newer triangle, which is the larger triangle in this case, 14, which reduces to 3 over 7. In number 2, write a similarity statement and state why the triangles are similar, then solve for x and y and find the ratio of sides. So in this case, we have the two triangles, one on the left and one on the right. Because this is a bow tie problem, we are going to have vertical angles are congruent at the vertex of C. And then using our parallel lines, we can use alternate interior angles so that angle A is congruent to angle E. So we're going to have triangle ABC is similar to triangle EDC by angle similarity again. So now we are going to solve for x. So A, B, and D, E are corresponding sides. They both have x's. So we have x plus 3 over 2x plus 13 equals, when I look at the other sides, I see there's a y, so I don't want to use that. So I'm going to use the 2 over 6. So as we cross multiply here, we get 6 times x plus 3 equals 2 times 2x plus 13. So as we distribute here, we get 6x plus 18 is equal to 4x plus 26. So as we solve, we get 2x equals 8. So x is 4. Then to solve for y, I'm going to keep the ratio of 2 over 6, and I'm going to use the sides with the y. So I would have 5 over 6y minus 9. So we have 2 times 6y minus 9 is equal to 30. 12y minus 18 is equal to 30. 12y is equal to 48. So y is also 4. Then for our ratio of sides, so if we used triangle ABC to EDF, I need a side from ABC, so I'm going to pick 2 over a side from the other triangle, which is 6. so this reduces to 1/3. In number 3, we want to write a similarity statement and state why the triangles are similar, then solve for x and find a similarity ratio. So in this case, we again have a bow tie problem, so we can mark our vertical angles are congruent. We could also use the parallel lines to show that alternate interior angles are congruent. So we would have triangle BAL is similar to triangle EKL by angle similarity. So now if I want to solve for x, I notice in the bottom triangle I have 3 sides with x. On the top though, I only have 2 sides labeled. So if I look and see that the parallel sides are going to be similar, so we would have x plus 8 over x. The other side from the first triangle is 9, which is going to be similar to the side that's x minus 1. So as we cross multiply, we get x plus 8 times x minus 1 equals 9x. X squared minus 1x plus 8x minus 8 equals 9x. X squared plus 7x minus 8 equals 9x. So this is going to be a factoring problem. I have to move everything to the x squared side. So x squared minus 2x minus 8 equals 0. So we need two numbers that multiply to -8 and add to -2. So we're going to have x minus 4 and x plus 2 equals 0. So x is 4 and -2. But if we look here and we put -2 into some of these sides in the bottom triangle, we would get negative lengths. So x is just going to equal 4. So if I'm going to do my similarity ratio, I'm going to put 4 in for x, so x minus 1 would get us 3. So we have a side from the first triangle 9 over a side from the second triangle 3, which reduces to 3 over 1. In our next problem, if triangle ABC is similar to DEF, we have AB equals 16, BC equals 28, AC equals 32, and EF equals 21. Find DF. So if we draw our two triangles, we have triangle ABC, 16, 28, and 32. Then we have our triangle DEF, where we know that EF is 21, and we're looking for DF, so we're going to call that X. So if we set up our proportion, we see that BC is similar to EF. So we're going to have 28 over 21 is equal to the side that has the X goes along with 32. So we have 32 over X. So as we cross multiply, we get 28x is equal to 672. Divide by 28. So x is 24, which means that DF is equal to 24. James gave his dad a model pirate ship for his birthday. The ratio of the model to the actual size is 2 inches to 5 feet. If the model is 16 inches long, 6 inches wide, and 4 inches tall, how many feet long, wide, and tall is the actual pirate ship? So we have 3 proportions we need to solve here. How long is it? How wide is it? And how tall? So we're going to use the ratio of 2 inches to 5 feet. So we're going to use 2 over 5 3 times. We know that the length is 16 inches. We want to know what it would be in the real life ship. So when we cross multiply here, we get 2x is equal to 80. When we divide, x is going to be 40 feet for the length. Then for the width, we have 2 over 5 equals 6 over x. That gets us 2x equals 30. So x is 15 feet for the width. And then for how tall it is, we know that the model is 4 inches. We're looking for the height, so as we cross multiply, 2x equals 20. We divide, x is 10 feet. So our length is 40 feet, our width is 15 feet, and how tall it is 10 feet. In number 7, find the coordinates of n in the diagram. And then what is the similarity ratio of EDO to CON? So first thing we want to do is we want to find the coordinate of n. So in order to do that, we're going to use the coordinates to find the lengths. So we know that from here, which is the origin 0, 0, to E is 4 units. And then from O to C is 8 units. From O to D is 3 units. We want to know how far is it from O to N. That will help us get our coordinate. So when we set up our proportion, I'm going to do 4 over 8 is equal to 3 over x. So as we cross multiply, 4x equals 24. When we divide, x is 6. So if the distance from O to N is 6 units along the x-axis, our coordinate would be 6, 0. Then what is the similarity ratio? So EDO is the smaller triangle. So we have a side 4 over 8, which reduces to 1/2. A 6-foot post casts a shadow of 8 feet long. How tall is an antenna that casts a shadow 60 feet long at the same time? So we have two triangles here of something standing up and then the shadow on the ground. So we know it is 6 feet tall and it has an 8-foot shadow. Then we know we have a longer object standing that we don't know how tall it is, but it has a 60-foot shadow. So using our corresponding sides, we can set up a proportion. So we have 6 over x is equal to 8 over 60. So as we cross multiply, we get 8x is equal to 360. When we divide by 8, x is going to equal 45 feet. In number 9, Jenny is 5 feet 6 inches tall. She is standing 4 feet from a lamppost, and her shadow is 7 feet 3 inches long. How tall is the lamppost? So in this picture, we have the lamppost, we have Jenny, and we have the shadow. So we're kind of creating a triangle here. Now, because we have feet and inches, we're going to convert everything to total inches. So if Jenny is 5 feet 6 inches, 5 times 12 plus 6 would get us that she is 66 inches tall. 4 feet times 12 inches is 48 inches. And 7 times 12 plus 3 is 87 inches. And we want to know how tall the lamppost is. So really we're looking at two triangles. One created by Jenny, and then one created using the lamppost. So as we set up our proportion here, we would have 87 over the full length of the side. So when we add 87 plus 48, we get 135 inches over Jenny, which is 66 inches, and we want to figure out how tall the lamppost is. So as we cross multiply here, we get 87x is equal to 8,910. So when we divide by 87, we get x is about 102.41 inches. In number 10, find x and the two parts of the base. Round your answers to the nearest hundredth at the end of the problem if necessary. So in this problem, we don't know the base at all. We know the full length is 60, so I'm going to call part of it y and part of it 60, the total, minus y, which is the part. So we really have two triangles that are overlapping with the same base. So we have this first triangle that I'm going to redraw over here. We have 25. We have a line inside that's x. And then we have y, 60 minus y, and we know this whole side is 60. And then we have the triangle from the other direction, or the taller triangle. So we're going to redraw that. So we have 75x, 60 minus y, and that this whole length is 60. So we're going to set up two different proportions. So looking at the first triangle, when I set up a proportion, I'm going to have x over 25 equals 60 minus y over 60. So when I cross multiply here, I get 60x equals 25 times 60 minus y. So 60x equals 1500 minus 25y. Okay, now I'm stuck because it has an x and a y. So I'm going to go to the other problem. In that problem, I have x over 75 equals y over the full length of 60. So as we cross multiply, 60x equals 75y. Now, because these both have a 60x, we can substitute. We can ignore the x and we can solve for y. So when we put these two equations together, 1500 minus 25y equals 75y. Move over the 25, so 1500 equals 100y. So y is 15. So our bases are going to be 15 and 45. We still need to find x, so now that we know the value of y, we can substitute back in to find x. So I'm going to take the second problem because it's a little less math involved. So 60 or x over 75 is going to equal y over 60, but we now know y is 15. So 15 over 60. So as we solve, we get 60x equals 1,125. When we divide by 60, we get x is 18.75.